Okay, we'll just start. Well, welcome everyone. My name's Noel Tomney of Wood Mackenzie, and we've got a session on green ammonia. Now, there was quite a bit of discussion earlier, particularly from on the opening sessions about ammonia, about the role of ammonia in marine sector was mentioned, and also some folk talked about referred to the idea that the levelized cost of hydrogen, of green hydrogen, seems to be guaranteed to come down, and but now the focus needs to be on transport in order to get transport costs down, and ammonia as an energy carrier for hydrogen is key to that as well. So there's quite a number of elements around the future of hydrogen that's related to ammonia, and also the ammonia as a decarbonisation of the existing ammonia market, which is in itself is very key. So with that, let me start with Andrea Guatoroca, who's the Stakeholder Relations Manager for the Ammonia Energy Association. So Andrea, could you introduce yourself first and tell us a little bit about the existing ammonia market so that we're all got a better idea about the role of ammonia at the moment?
Yeah, of course. So can you, I'm Andrea Guatoroca. The pronunciation was perfect, thank you. I'm the Stakeholder Relations Manager of the Ammonia Energy Association. It's a global trade association that aims for the responsible use of ammonia in a sustainable energy transition. And we are now more than 150 members. And well, of course, we know ammonia can be, we know for fertilizers, as a fuel, for energy, as an energy carrier, but I think we need to address first the amount of emissions that comes from fertilizers. So that represents 1% of greenhouse gas emissions, and that we have this market to transition to a green ammonia, well, low carbon ammonia potential. And we are actually going to launch in 2 days a report we produced with ARENA about the outlook of ammonia, so renewable ammonia and what is the market, cost competitiveness. And we are looking at this scenario of 2050 in a 1.5 degree scenario where we have a 688 million tons of ammonia market. And of course, so this highlights the importance of transition to low carbon ammonia.
Great, thanks Andrea. I wonder, do you think someone could close the door at the back? Sam, could you close that door? It's just quite noisy up here. Thanks. Okay, let me turn now to Tor Lohman, who's the Executive Director of Fertiliser Methanol at ThyssenKrupp Ud. Tor, could you tell us, introduce yourself, and also tell us a little bit about current ammonia forms of production and how you think that might change as we moved to a green ammonia product?
Yeah, we from ThyssenKrupp Uhde, we are now 101 years. So last year we have had our 100 years anniversary in the ammonia market. So the company has been founded by Mr. Uhde, therefore the name, and he invented a special part of the ammonia Haber-Bosch part. So therefore we are in that market, and over the last 100 years we have seen a lot of development in electrolysis, in the technology as well as also in the market. So currently the largest market for ammonia is definitely the fertilizer market. It's representing roughly 90% of the 200 million production of ammonia, what we see every year. And we have seen in the 70s already a development from the coal-based to the gas-based fertilizer and the CO2 and the hydrogen production. And what we're currently seeing then is a shift from the gas-based to the electrolysis-based or green hydrogen-based production. So therefore, for the ammonia market itself, it's another feedstock change, what will simplify the plant, of course. And with the same impacts also, we talk about competitiveness from the one feedstock to the other feedstocks. And we see also that we have now a complete new application in the plant. Andrea pointed that out already. That is now the carrier discussion. So is ammonia a good carrier for hydrogen in the global market, or are that other substances? That is therefore important to differentiate between these two different sectors. So we have the classical fertilizer sector, and we have the energy sector, where now ammonia is an energy carrier, or even an energy part to be burned directly. And that's for us, of course, first of all, a huge opportunity, because there's additional market coming up. That's nice. But on the other side is also, that is a complete different market with different mechanism and also technical requirements. We talk about a classical ammonia plant is running 100% stable. Another plant in the renewable sector is going up and down, and even in the minutes. So the dynamics are quite differently. So therefore, it's a challenge from us as a licensor and technology company, but it's an interesting challenge what we like to take. And we are quite convinced that, especially in the second market, so the hydrogen carrier market, ammonia is well placed, because it is, first of all, it's there, it's available, so we can build plants up to 6,000 tons per day. If we talk about the competing technologies, they are on much smaller scale or even under development, so therefore it's ready to use. And it's also for the developer, I just discussed it some minutes ago, and market what has the opportunity, even if the energy market is not absorbing the ammonia, the traditional fertilizer market, it's still there. It can be sold in that market. And the third part is also, of course, ammonia, it's a chemical substance, so therefore it's not easy to use. It needs professional hands, but the professional hands are there. So we have already a market and shipping system established globally with 20 million tons shipped every year, where we have workers who can deal with ammonia at the end of the day. And that's the all 3 points are very important then, what makes us believe that ammonia is the right substance to ship then also green hydrogen at the end of the day.
Great, thanks very much, thank you. And Dan, if I could turn to you, Dan Feldman, who's a partner for project development and finance in Shearman & Sterling. Dan, if you could introduce yourself and tell us a little bit about some of the projects in which you're involved related to green ammonia, that would be great.
Sure, many thanks. So my name is Dan Feldman. I'm a partner at Shearman & Sterling. Shearman & Sterling is a global law firm headquartered in the US. We were the first law firm to have a global hydrogen industry team, and I head that team and the firm's energy innovation practice more generally. We were fortunate to be involved, and continue to be fortunate to be involved, on a number of the largest green ammonia and most developed green ammonia projects worldwide, in Saudi Arabia, in Oman, Morocco, Canada, and elsewhere. The first project that we got involved with, which is the most advanced green ammonia mega project in the world, is the Helios project in Neom in Saudi Arabia. This is a project that will produce 1.2 million tons of green ammonia from 2.2 gigawatts of ThyssenKrupp electrolysis, all of which will be off-taken by Air Products, an American industrial gases company, and shipped to Europe and elsewhere for regasification and use in the mobility market. And we have worked on that project alongside Aqua Power and Neom and Air Products for about 2.5 years now. That project is at the end stage of its limited recourse project financing. So we're about to achieve financial close on it. Construction has begun, and that will have ammonia loaded onto ships late 2025, early 2026. So this is the first project to go from inception all the way through the entire structuring and financing process. And so from that point of view, it's given us a very good, I think, overview of how to structure a bankable green hydrogen project or green ammonia project, as well as the sorts of uses that ammonia might be good for or not so good for. And in addition to that, we've been fortunate to work with off-takers, so looking at it from the other perspective. And off-takers clearly have a different view on what they need to see from projects, and that's been a fascinating counterpoint to working on the supply side. So all in all, it's been a very interesting journey for us so far, working on projects of different sizes in different jurisdictions, coming at it from different perspectives, and there's no doubt that this is a very important vector for green hydrogen development going forward, and one that I think is going to result in some quite significant developments over the next 6 months.
Great, thanks, Dan. Maybe we could start with thinking about some of these new uses for ammonia. We'll come back to some of the traditional market elements later. But if we start with some of these new potential uses of ammonia as a fuel, Tor, you referred to some of those possibilities. Andrea, could I start with you? I mean, which direct ammonia applications with ammonia as a fuel most excite you at the moment?
Well, I think that I would say the replace diesel genset. I think is the one that excites me the most. I think there is a lot of potential for emission reduction with small scale power distribution, which sometimes is far off grid, and it allows, it gives ammonia a very important role. So yeah, I would definitely say yeah.
And Tor, what do you see as some of the more significant in terms of perhaps volumes? And I mean, we heard about marine this morning being used, but we haven't heard too much about power. Could you tell us a bit about power?
The power market, I would see, is in the future. We see it currently as a 20% addition to conventional plants in Japan. They're testing it currently. They're testing also gas turbines with direct fuel of ammonia. That's of course very interesting. Then I believe very much also in the marine sector, so that will go into the ammonia, because also there the handling issue is quite easy to manage at the end of the day. But at the end of the day, it's also the whole fertilizer market, what's still there, and we heard it in the morning. The fertilizer market is contributing roughly 7% to the global CO2 emissions, and there, of course, it could be the first step to get the ammonia there in where it currently also, as we did it in the 70s, as I referred to. But interesting-wise, currently we see not the first projects coming up in that market. The first projects are really the energy carrier instrument from or connecting then the solar and wind-rich countries with countries who have a high demand, for example, Australia with Germany, or Chile with Germany. So in Germany we have not so much sun, and the wind is also relatively limited compared to the demand. So that are currently the first projects, but definitely the whole fertilizer sector will come sooner or later. We believe after 2030, definitely it will be competitive, and then more or less every fertilizer company is going there. Unfortunately, OCP is not there. For them, of course, it's a huge opportunity to be in a country where they have no gas resource or limited gas resources, and then can step into that market. They're currently an ammonia importer. And that is opening, especially for Africa, huge potentials also, because you have many countries you can build decentralized smaller ammonia units with the direct renewable energy connection, and also then the production of ammonium nitrate as a nitrogen fertilizer. And that is unlocking markets what are currently in the traditional fertilizer market are not there, besides the discussion what we have seen in the morning also.
Let's come back to ammonia as a carrier in a little bit. But if I could just pick up on your point about, you seem to be getting most excited about ammonia, green ammonia actually displacing grey ammonia in the fertilizer market. But really, I mean, the fact is that it's going to raise food prices. I mean, so if we start getting more expensive fertilizer products, don't we?
And exactly that should not happen. So the fertilizer market will pick up at that moment where the green hydrogen is competitive against the hydrogen coming out of the steam reforming. That will be the point. And then the fertilizer will be not more expensive. And that's exactly how the market mechanism is working there. But on the other side, I'm also happy that in this conference will be launched now the green hydrogen standard, and that is then the first step to define also a green hydrogen standard, and consequently then also a green fertilizer standard. Because if then the product can be labeled, then of course also customers are willing to pay a premium. Currently the fertilizer is fertilizer and they cannot distinguish between green or gray. But I fully agree, the driver for the fertilizer market is the food industry, and the food industry will not absorb additional costs there in the fertilizer market.
Dan, what do you think? Do you see the fertilizer market as the big current driver for green ammonia, or do you see something else?
Yeah, I do. I mean, I think I agree with many of Thor's comments, up to the point where I think we get talking about a discussion about price and what that will do to fertiliser, and I think maybe have some different views on that. I mean, I do think that the initial project will be delivering green ammonia as an energy carrier, and I think the NEOM project is a good example of that. I then think, I completely agree with you, that the next sort of most obvious use is marine fuel, for the reasons you gave. There's enormous demand for it. Clearly the off-takers are there in the early stages. It's a relatively easy use application. I mean, in general, you want to keep green ammonia as ammonia to the extent you can when making it and applying it at scale. I think as well, fertiliser, and I'll come on to that in a second, but also we're seeing quite a lot of pull from Asia for green ammonia for power. JERA, the Japanese utility, has launched effectively an auction process, a reverse auction process to bring ammonia to Japan for this process and co-firing in power stations. And there's a lot of, not skepticism, but there's questions about the economics of doing that, but it's clearly something that they take very seriously, and that's proceeding quite fast. On the question of fertiliser, I mean, we acted for OCP on an agreement with Shell to do initially a green ammonia, and it's a shame Hanan's not here, but to do initially a green ammonia pilot project, essentially mapping out the green ammonia, the optimal sites within Morocco, and then with a view to a larger scale project which would have two purposes. The first would be to replace the gas that Morocco currently imports to produce ammonia for fertiliser with the use of the Moroccan existing natural resource. So in other words, instead of spending enormous amounts of money importing gas to make ammonia, you would just use the Moroccan sun, wind and land to produce your own ammonia, displacing not only the huge economic cost of importing gas, but also creating an export opportunity. So completely reversing the economic situation that Morocco is in at the moment. When you then look at the cost of that and the sort of purported green premium that green ammonia would have in the fertiliser market, at the moment, and I think we are at a certain moment in the economic and geopolitical cycle, but at the moment there's a green discount to green ammonia, which is to say that it's cheaper to produce green ammonia than grey ammonia, and therefore cheaper to produce green fertiliser in theory than grey fertiliser. And because we don't have the scale of molecules to be able to demonstrate that as a commercial matter, we can't validate it. But if you believe that the trajectory of carbon prices, the volatility of gas prices and so on is something that will continue or is something that to be expected in future, I think the combination of reducing solar costs over time, reducing green hydrogen costs over time, and not only that, but the natural hedge that hydrogen provides, because unlike the gas price, it doesn't fluctuate. Essentially, once the capital is in the ground, you have a fixed price, very low marginal cost product. And there's a lot of value to that if you're an importer of gas. So I think actually the fertiliser story is very important, and I think it will happen more quickly than perhaps others do.
Can I?
Yeah, Andrea, go on.
So I like to say about the maritime sector. So it is, I'm completely agree with Dan, for the maritime sector with ammonia is the fastest growing market. And we see continuously all the projects that are coming out, new investments, new developments, new engines for 2025. And in the Ammonia Energy Association, we keep looking at all these amazing projects that are being developed in the maritime sector. And we actually have this webinar series, and we have ammonia for bunkering in Singapore. So it's a really exciting time for the maritime sector and ammonia.
Tor, do you want to make a point?
Yeah, I would agree to Dan also to that statement. So it depends mainly on the region and in which countries we're talking about. So if we see currently the situation in Europe, there we have gas prices from over 20 euro per million BTU. So that is 10 times the gas price of the Middle East, for example, or the US. There, of course, green hydrogen would be competitive if it would be available. So it's double wood, and that's currently the problem. So there is not enough renewable energy available in Europe in order to produce then the green hydrogen, and that's more the point there. And then, of course, starts the question, will the European fertilizer industry import now green ammonia from Saudi Arabia via NEOM, or will they directly build the new fertilizer plants in Saudi Arabia? And our bet is more the new plant will be then built in Saudi Arabia, because also the gas-based fertilizer plants are shifted from Europe to Saudi Arabia in the 70s. So the coal base were already in Europe, and significantly they went down due to the gas prices. And something similar will be happened then also. The power price is very low in these countries, and therefore also that industries will follow then simply the energy opportunity to go there.
So Dan, you referred to JERA looking for procuring ammonia, or low carbon ammonia, although they've gone for blue ammonia in this instance. And Tor, you referred to Japan and Asian countries as well in the power sector. So this is both to displace coal in coal boilers, and also potentially actually to use ammonia directly in gas turbines. And it does seem to be something that offers a lot of potential for Japan. South Korea seems to be quite animated about it. And I think we're going to start seeing quite a bit of movement in China in this regard as well. If you start looking at all those coastal regions with existing boilers, there's the most enormous market. And Andrea, we don't seem to be seeing a great deal of movement for ammonia in the power sector in Europe. Is this something, do you think, that will change?
For ammonia?
In power, yeah. Do you think it's something that
Yes, definitely. I think that if you ask me that question in 1 year, I'll be able to say like this whole amount of projects. In 5, like I'm sure it will be like applications for ammonia for power will be massive, but at the moment it is not as developed as as ammonia for maritime, for example. There are still some challenges that are still need to figure out, more time to develop the engines, all for ammonia for power. So we are moving. Well, I think that all the projects are moving with the ones that are bringing the more stability.
Yeah, understood.
And also the power industry is not that advanced in Europe to cope then also with ammonia. So we have seen that in the 80s, when also the SCR conversion system will be introduced to reduce the NOx emissions. This industry is very shy if it comes to chemicals. And therefore it will take a certain time, and forerunners like Japan until they will also go in this direction. But if you see currently, the idea in Europe was to have as an immediate step then gas-based power plants, and due to the geopolitical situation, that will be not an option for the intermediate period, and there I think ammonia will play a dominant role. So therefore the sad it is with the conflicts we are seeing currently on the ground in Europe, it will accelerate exactly that movement from the current industry, from the coal-based industry, into a low carbon or even green industry in the future. And there, ammonia will play a very important intermediate step than what is currently covered by gas.
Yeah, I mean, there's a looming problem in Europe, which is what is the base load? What is the base load energy source? And I think people are settling on hydrogen, some sort of hydrogen derivative, whether that be piped hydrogen or whether it, with line pack, or whether it be ammonia that can be stored locally. But clearly there needs to be a solution probably hydrogen-based around that. It would make sense for ammonia to be a part of that solution. But again, the economics of ammonia co-firing and so on are still, I think, as I say, people have skepticism about that.
Let's pick up a bit more on that and some of the infrastructure issues in a moment. But if I could just jump to green hydrogen as an energy carrier. I mean, Dan, you referenced the NEOM project. You've been looking at other projects in which ammonia is being proposed. Why are folks not taking liquid hydrogen or liquid organic hydrogen carriers or compressed hydrogen more seriously? And do you think it really is all about ammonia as a means of transporting long distances?
Yeah, it's a good question, and I think it's a moment in time, which is to say that these projects are looking to get to market as quickly as possible, and ammonia is perceived as the quickest, cheapest way right now to do that. That isn't to say that liquefaction of hydrogen won't have a very significant role, and indeed there are major players for whom liquefaction is ultimately the idea, that we will have ships sailing with hydrogen and not derivatives of hydrogen. And that makes an awful lot of sense if we can solve the engineering challenges, because the alternative, which is to use ammonia as a carrier, has its own set of significant issues, including the scaling up of crackback technology, the scaling up of import terminal and storage, moving ammonia about the place, So I think this is the way in which the industry is evolving early. The off-takers of ammonia are intending to use it for many different purposes. In fact, of the projects that we're working on, every one has a different use application for the ammonia that's going to be sold. NEOM is mobility, so hydrogen. Another project is for use in chemicals in Europe. Another project is bunkering. Everybody has a different application, which speaks both to the flexibility of ammonia, but I think as well the people taking a different view on what is the best place to sell ammonia right now.
Yeah, that's very good. And Tor, I mean, you referred to ThyssenKrupp as having equipment capable of producing 5,000-6,000 tons a day of green ammonia, but there's quite a different sort of capacity when it comes to actually cracking the ammonia. What's the current capacity of a plant to do that, and how do you think that might evolve?
That's definitely in a very small scale currently. So we are in the development of a project for scaling up exactly that technology, and we will announce it hopefully within May. And there we're talking then of a pilot plant of 40 tons. And that will be the first one. The beauty is currently that we're not talking about a new invention of a technology. It's really a scaling up. And scaling up, it's always easier than inventing something new. The equipment is known also, so it will be the same technologies than the steam cracking. So we have a gas-fired cracker technologies there, and that is known, and the gas what we are firing will be then also ammonia. So therefore it's a system what is also completely low carbon or no carbon emission at that point in time. So therefore we think within the next 2 years the scale of the technology will be tremendous going up, and then we are talking about also about some 100 or some 1,000 tons per day production with such a decomposition plant. But also we believe that these plants will be more in some area decentralized, so the customer will directly have that, so there's also not the need for that large scale. And on the other side, especially in Europe, you have then already hydrogen networks in Rotterdam, for example, where you have one of the feeder stations, and there will be then large-scale plants what will feed then the whole system.
Now, it's a very endothermic process, requires a lot of heat, a lot of energy. I mean, it's quite eye-watering, isn't it? Over 30% losses involved in getting ammonia back to hydrogen. If you want a high-quality hydrogen product.
I don't want to bore now everybody with thermodynamics and physics here, but also the other alternative cooling down hydrogen to minus 253 degree requires a lot of energy. So therefore, it's a comparison. It's really cold, yes. And at the end of the day, it's about economics. And there always I like to refer to the high supply study from the German and Australian government, what they have published, and they have compared the different possibilities. And even with that additional energy required coming again from ammonia, the lowest price opportunity is with green ammonia. But the market mechanism at the end of the day will show the thing. So we can debate endlessly on the three opportunities. Fact is that ammonia is ready now at a certain scale, and the others needs to be developed. So we have simply the early mover advantage, and that definitely will be used by the industry.
Just Andrea, on that early mover advantage, I mean, is this what the Ammonia Energy Association tells itself and its users, that you know, once ammonia gets established, you know, who's to say it should shift? I mean, won't it just become the dominant?
Is established, like is now. So sometimes we talk about this futuristic technology or something that will happen, but it is happening now. We can see it with NEOM in Saudi Arabia, Hyex in Chile, Puerto Llano with now Iberdrola and Fertiviria, Townsonville in Louisiana, Norway, a lot of projects. And all of these are under development, moving forward, not for something that's in 10 years, but moving forward for 2024, 2025. And yes, it is a reality. I think we are living in very excited moment for ammonia technologies, ammonia as a fuel and carrier, because it's happening. It's not just design phase that we just imagine. It's actually happening now, and we have the projects all around the world.
If I could just stay with you, though, I mean, one of the big challenges associated with ammonia and its broader adoption is toxicity and its perception, how it's perceived. I mean, how do you think that's going to, some of the hurdles associated with that are going to be overcome?
Well, that's a great question, because part of my background is I actually did research for 5 years in public perception of green ammonia. So a lot of years working with ammonia. And yeah, sometimes when we develop new technologies, we focus on the physical and technical properties of these technologies, and sometimes we forget societal implications, or we look at this until the last stage of the technology. And sometimes technologies can be great for the environment, can bring a lot of benefits, but still have public opposition, like we see wind turbines in the UK or around the world. So in the research that I've done, I've seen that, yes, maybe ammonia can have ammonia perception as alone, that word might have like not a very positive perception, but once you frame that ammonia as a way to tackle global warming, as green ammonia in the context of climate change, then that perception changes. And here is where I say, like, it's funny that you mentioned toxicity, but in the research that we did 2 years ago, for example, we ran this study in Mexico, and for public perception of green ammonia. And yes, of course, I'm sure toxicity will be one of the worries and everything, but people, when they were presented with green ammonia or ammonia as a fuel, they were worried about the government. They were not thinking about how is the toxicity. They were saying to me, who is going to develop this technology? Okay, I hear hydrogen. Hydrogen is water. Water, we have a problem of water scarcity in Mexico City. Are you going to take that water from me? So there are things that sometimes you assume that people will be afraid of toxicity, but there are other things that we are not taking into account. So we need to involve public from like an early stage of the technology development.
And Tor, in terms of the infrastructure development, if you take Northwest Europe, you referred to maybe breaking bulk and decentralized units and centralized units and different forms of infrastructure. So it'd be interesting just how ammonia infrastructure develops, and I can see lots of different ways. Do you think we'll get ammonia pipelines in Europe?
As far as I know, we have already ammonia pipelines in Europe, so there are some. And some of the, or nearly all of the power plants are getting ammonia via ships already for their emission system to reduce emissions at the end of the day. But at the end, we see it similarly. Ammonia needs to be in professional hands. So we don't see that it will be an end customer product where I have in my house an ammonia tank feeding my heating system or my car at the end of the day. So it will be an application for power plants, it will be an application for the chemical industry, for the fertilizer industry, and they know already how to use, and they're using it already. So therefore, the risk is already there. It's a scale. Yes, it will be more there, but as long as you know how to handle it, as I said, 20 million tons per year will be produced ammonia, but rarely we see any ammonia incident currently in the public, and there are other substances quite more in focus at the end of the day. And if I compare that again with the competitors like the liquid organic hydrogen carriers, they will talk about toluene. So toluene is also not something what you can drink, and therefore there will be the same debate, not yet, later, and again, professional hands will handle it, and then it's also good to do so.
Dan, in terms of financing these ammonia focused hydrogen projects, and specifically green hydrogen projects, green ammonia projects, how do you think the green hydrogen standard could help?
Well, probably two thoughts. Firstly, there's enormous appetite on the debt side for well-structured green hydrogen and ammonia projects. I mean, as I say, we're nearly through the NEOM project financing. This is a limited recourse utility style financing, essentially. And I mean, the appetite is enormous. So provided that the projects are well structured, they have sponsors with good track record and so on, they are entirely bankable, and the model that we are developing at NEOM is designed to be portable. So we could pick that model up and drop it in Australia, North Africa, Canada, wherever, because it relies on no state subsidies, and provided that you've got strong sponsors and off-takers, it's a model that is entirely replicable. Having said that, the lack of regulatory certainty is awful. It's absolutely awful. As a lawyer, I spend the majority of my time picking through Red 2, Red 3, draft delegated acts, and trying to advise clients who are about to invest billions of dollars into an environment not only where the market is uncertain, but the definition of the product is uncertain, is difficult. And the way in which you're left to finance projects in that environment is very conservatively. They have to be structured very conservatively so that no amount of sort of regulation could strip the greenness from the project, and that involves things like direct connections to electrolyzers, none of which are particularly ideal from an economics point of view, because you get a lower load factor than you would if you could connect to grid more easily. So none of this is good. None of this is good, and I think the emergence of a green standard that reflects reality of doing business and financing projects will be a massive boost. That's not stopping people, though. And it is possible to do projects at good rates of return without it. But I think if we can strip back the regulation that's currently really creating uncertainty and concern, it will be a further significant fuel to getting projects moving.
Great, thanks. Andrea, what about you in terms of the green hydrogen standard and the even the fact that when JERA did go out to market for that 500,000 tonnes of blue ammonia, I think they stipulated a carbon capture efficiency of only 60%, so they're not looking for a particularly green product. Do you think the green hydrogen standard will actually enable a premium product to get rewarded for having better rewarded for having a low carbon emission?
Yeah, so I think green hydrogen standards provide market signal of availability and and credibility. So, for example, like it's not futuristic, it's something that it's happening now, decarbonizing the supply chain in a decade or less. And also, consumers need to know the carbon intensity of the products. So, developing, going with an IPHE methodology and this globalized harmonization, of course, is very easy. It's very helpful, sorry. And in the Ammonia Energy Association, we are, as a trade global association, we are working with all our members to create the certification scheme for ammonia and looking for the correct and way to measure and quantify carbon emissions. And of course, hydrogen as a carrier, ammonia as a carrier of hydrogen is also considered in the certification scheme. And we are constantly inviting organizations, ammonia, hydrogen, to provide input to all this new certification scheme and make it as global, harmonized, and be able to implement it maybe for next year. We are now in an engaged design phase. So we are now getting like all the help and input from all the organizations, and then we are expecting in 1 year maybe to implement this new certification scheme of ammonia.
Great, thank you. Tor, do you think that that it will help attract a better price as well for a premium product?
As I said, it's the first step now, and that's a very important step, and it's really excellent that that will be done now. And subsequently, the next step is then what is green ammonia, and then also what is green fertilizer. So the ammonium nitrates is relatively easy, so that's just burning ammonia, and then you're getting the salt out of it. The more tricky part will be then the urea, and that is currently the largest market of the fertilizer. We believe that there will be a definitely shift from urea to ammonium nitrate, so that the more prominent substance is ammonium nitrate or calcium ammonium nitrate, because you have with the urea the question of where's the CO2 coming from. So therefore, we are not talking about a decarbonation of the industry, it's more defossilization of the industry. But especially for urea, it's another thing than for methanol, what you use as a chemical substance. Urea, you are producing it, and then you, within 1 year, you will put it on the field, and then the CO2 will be released. So therefore, it's not really a storage of CO2. So therefore, that question needs to be really answered. Can anyhow urea ever be labeled as a green urea? From my point of view, not. So, and what is then the answer to that industry at the end of the day? And that is also going for methanol. So where's the CO2 coming from? And what prerequisites needs to be that the methanol is also a green methanol and not an half green and half gray methanol at the end of the day.
Great points. Thank you. I'd like to open the forum to the floor. There's a very enthusiastically raised hand over here.
Hi. Yes. My name is Rolf Bernson. Thank you. I'm very, enthused about the conviction, the enthusiasm they have really for green ammonia working. When I've talked to companies from different number of countries, developers, they've all told me I can't get any offtake. I would have assumed that especially in the fertilizer industry, where it's just not new, but existing, where you just switch from gray to green, it would happen much quicker. I agree with what you said, like ammonia should be clear, like you've got absolute price stability, you don't have the volatility of gas. So help me with the puzzle, why isn't green ammonia taking off quicker? And from the point of view of the off-takers, why aren't fertilizer companies really engaging and giving long-term contracts for green ammonia? Thank you.
Well, I think they are. So, I mean, if you look in Oman, you've got Yara, off-taking from one of the projects there. Obviously, you have Air Products. There are other projects that are about to announce green ammonia off-takes. You have JERA pulling from Asia. I don't think there's a shortage of off-takers. I think there's a...
But are you talking about green, or are you talking about low carbon?
Green. So I'll talk about JERA in a minute, because JERA is agnostic, really, as to the colour. But I think Uniper as well is off-taking green ammonia from Oman. There is no shortage of off-takers. I think actually it's a combination of credible developers, because of course, you know, these things are done on an integrated basis. If you are an off-taker, you need to have visibility not only into the, you know, there's an element of sort of buying the seller here. In other words, I'm not just buying the product, but I'm engaging in a partnership now with someone who's going to develop a new project, which you know, relies entirely on me. But I need to understand how the cost is built up. I need to make sure that the product's going to be there when the developer says it's going to be there. And so these things are done in partnership, and therefore I think it's an absence of well-structured, advanced projects rather than an absence of demand. We're also seeing enormous demand increasing, and I think the E.ON deal entered into with FFI from Europe demonstrates the enormity of the demand. The question is not, can I find an off-taker, but I think it's, do I find the right partnership? And I think the NEOM story is a good example of that. I mean, that was 3 players getting together, one renewables developer, one sort of state entity, and one off-taker, effectively, getting together and leveraging their different skills, and with a joint venture that's entirely transparent to all parties. And it's that kind of collaboration that I think leads to success. But expecting to just sort of build a project and then wait for the off-taker to come, I think is not the way any new industry really emerges.
Tor?
Yeah, and also the majority of the fertilizer producers, they are not buying ammonia. So just 10% of the global ammonia market is traded. So the large majority is direct to produce as an intermediate product in one complex. And then, of course, the plant is there, and as long as that is working and is competitive, why they should subsidize that? That is mainly the question. We see it currently in the market that new projects are very rare. Dan just talked about the possibility of financing green project, what is nice. What we hear from our customers is that it's getting harder and harder to get a gray project financed. And that's currently the intermediate period where we see that the gray projects are dropping down. They are not any longer there in the market. And the green projects are now picking up slowly. And there, the main problem is currently really the availability of renewable energy. And that's really where is the lack, and not the ammonia plant. As soon as the green energy is there, the electrolysis is there, the ammonia plant is just a walk in the park.
So kind of related to this then, I mean, I know we're not really allowed to talk about blue projects, but are you going to get some sort of transit? Do you think some sort of transition where there's going to be some blue, where you see existing, particularly from existing grey projects who are going to add some CCS on, is just kind of inevitable?
So we're acting for ADNOC on its blue ammonia project, which involves Fertiglobe, so it's a Dutch fertilizer company, Mitsui, and GS of Korea. And they're going to create a project which essentially is an ammonia loop, but through that loop will be fed all sorts of different hydrogen. You'll have pink hydrogen, you'll have green hydrogen, you'll have blue hydrogen, you'll have grey hydrogen, effectively creating a menu of products for the customer. And different customers have different needs and prepared to pay different prices for different qualities of hydrogen. You end up with a project which is entirely fully utilised, essentially, and depending on the cost of production of any given hydrogen feedstock, you can really optimise the use of that asset. And I think that kind of model is the one in which blue hydrogen may have a role. Not a project that is set up to permanently produce blue hydrogen, although we will see that in certain European industrial applications, I think, like chemicals. But in general, you wouldn't be setting up a project to sell blue hydrogen alone. I don't think that is a thing that we really foresee happening because of the risk of the stranded capital.
That's interesting. I mean, Tor, what do you think? Or do you think that the actual capital to get from grey to blue for some of these projects is actually not that high?
one other interesting setup is then also a revamp opportunity. So you have a traditional gray plant, and you can set up then CO2 removal in order to get it blue, and that is then an advantage, especially for the newer plants. But every new plant currently, the consideration is always, are we going for a gray plant? There is a clear yes still if I'm getting the gas price around $2 per million BTU. If that price is higher, it will be currently not built, and they're waiting simply then for the next step to go to green ammonia then.
Yeah, thank you. Any other questions? There's a lady at the back here. Thanks.
Hi there. Thanks very much for this very interesting panel. You spoke briefly before about the toxicity of ammonia, and you were talking a bit about the public perception. But I was wondering if you could elaborate a bit more about how it's possible to mitigate the practical risks of the toxicity of ammonia, particularly if we're talking about large-scale exports. Thanks.
Tor.
I would simply say the large-scale export is currently there. So we talk about 20 million tons per year, what is generally or globally traded, and the installation is there. But it requires a professional handling at the end of the day, and also workers who knows how to do that at the end. And that is available, and therefore we don't see major incidents around the world. And if that would be now on another scale, I do not expect that that will change dramatically then. And the second thing is the fear, of course, and that I think Andrea is referring to, is something not rational. And one advantage of ammonia is simply it could be smelt. So therefore, the fear is not so high than in other technologies.
Yeah, I've heard people say this before, but I wouldn't want to have to outrun a toxic ammonia cloud.
But at least you know you will need to run. Because then you would start burning all your face, and you need
that's nice.
to go.
I mean, nothing's perfect, right? And we're trying to avert what the public tells us is they are very concerned about, which is climate change. So, I mean, it's pick your evil. And I think, as Thor said, ammonia has been used for 100 years. I mean, there's no greater safety issue with ammonia per se than there is with natural gas or hydrogen for that matter. So, I mean, there are issues that need to be managed, but there's no reason to sort of look at ammonia and think that, we ought to be going in some other direction, not that there are many other directions, simply because of the risk of, or the perceived risk of toxicity.
Yeah.
Yeah, and it's very important to take also this fears seriously. So it should be not simply wiped away. So yes, it is toxic, and therefore professional handling is required. And that's the important part of that.
Yeah. No, it was great. I thank you very much. Thanks, Dan. Thanks, Andrea. Thanks, Tor. That was super interesting. Thank you very much.
Thank you.
Thank you very much.
Thank you.